Greetings, Earthlings! Before we start exploring, don't forget to like, comment, and subscribe, wherever you're listening. It helps more people find the show and supports our mission of making science accessible to everyone. You're here with DJ Stellar Cloud. Thank you for tuning in. Welcome back to the Exploring Your Universe radio show. Exploring Your Universe is UCLA and LA County's largest science fair. We just so happen to be cost-free, and this year we are on Sunday, November 2nd from 12 to 5 in the UCLA Court of Sciences. You're listening to DJ Stellar Cloud, and...
I'm DJ Solar Max.
DJ Solar Max, aka Max Parks, is a graduate student here in the EPSS, that's Earth, Planetary, and Space Sciences Department at UCLA. And he's a pretty cool dude, so he volunteered for the booth Diviner, the Moon and Infrared, which you heard about in the episode with DJ Stat Sleuth a few months back, and he's been in EYU since before I have. So tell us all about Diviner, the Moon and Infrared.
Sure. So the group I work with is the Dave Page group here at UCLA, and we have the opportunity to be the sort of primary instrument team for Diviner. Diviner is an infrared imager that is on the Lunar Reconnaissance orbiter, operated by NASA, and has been orbiting the moon for many years now. Mm-hmm. But it has, because it's an ongoing concern and you know...
Concern?
So, I mean, ongoing operation.
Sure. Okay.
And so it's got a long life. I mean, one of my friends worked with Diviner to study lunar pits and sort of the thermal maps of possible subterranean spaces. We are also very interested in using infrared to study volatiles, that is to say, like water ice that might be on the moon. This would be really important for human exploration, and so Diviner has a sort of a central role in a lot of different, both pure science and human exploration space ideas, space missions.
Cool. That was a lot of big words. Let's start with the first one, Dave Page. He's a cool guy. He won a very large award recently?
Yes. I don't know. He was on a team supporting a very large award.
Oh, got it.
Actually, I believe a former student of his, Matt Ziegler, he was the PI or principal investigator for a lunar ground-penetrating radar, basically a lunar scientific instrument that's going to be on the rovers that they drive around when NASA goes back to the moon. And so that's the thought, at least. You know, we have a strong moon heritage in this group.
Yeah, I hear about the moon a lot because DJ Stat Sleuth and I are very good friends.
I'm sure.
What is reconnaissance?
Reconnaissance is an interesting question. We'll get to my understanding of reconnaissance later, perhaps. But reconnaissance is the study of a landscape, both to assess resources as well as to just get a better understanding of, sort of a better holistic understanding of a space.
Sure.
Yeah. So
it's sort of like you're doing geology on the moon.
Yes, but specifically remote sensing.
Okay.
So when people think of geology, I'm sure most people think of going out into the field with, you know, cargo shorts and axes, right?
Yeah.
Picks. Whereas this is more like satellite imaging.
Okay.
So as, you know, I'm sure geologists use that too, but
I don't know.
it is more, when we talk about reconnaissance with specifically, you know, with our orbiters, we're talking about, you know, just imaging from space, getting sort of a whole planet sweep.
So we're doing Google Earth, but of the moon.
Yes, and in the infrared.
Yeah, that was my next question. What is infrared? Why is it important?
So infrared is different from visible light. I think Google Earth for the moon is a great example. So there actually is Google Earth for the moon. I think it's called Google Moon.
Oh, that's funny.
Yeah, it's pretty cool, and it's just the images of the moon's surface like your eyes would see. Mm-hmm. But infrared is a different kind of light. It is a longer wavelength than optical light, or the light that our eyes see. Mm-hmm. And it is infrared. Infra means sort of below, and red means red.
Yeah.
And so it is below red. It is a lower energy, and so longer wavelength than red light. Red being sort of the end of the rainbow, the R in Roy G. Biv. So that means infrared, we are seeing things differently. Rather than seeing gray on the moon, we see heat on the moon. And specifically, we look for heat differences usually with Diviner. You can just get a total temperature map. Basically, when you take a picture in infrared, you can get the temperature of a thing.
Is this how people do those thermometers where they like?
Those are
small,
infrared.
Yeah.
Yes, those are infrared sensors as well. When we take a picture of the moon, we'll take a picture during the day.
What is the daytime on the moon?
Right. So
Yeah.
it's called local noon, I
Sure.
think. But, you can break up the moon into 24 hours of rotation, but the moon takes like 29 days or 28 days to turn around.
Oh.
And so it is, each day lasts 2 weeks
This
on
is
the
the
moon.
full moon thing.
Exactly.
Okay. Yeah.
And so each day lasts 2 weeks. And if each day lasts 2 weeks, you can take a picture 1 week, or take a picture at the start of the 2 weeks and then take a picture at the end of 2 weeks, and you'll have both a day and a night picture.
Cool.
And then you can compare those two and see how the temperature is changing, and specifically how the temperature is changing. Sort of one region, one crater might change temperature faster than another crater, and that'll tell us what that crater is made of. You could think of it like if the hot pavement next to a grassy park. When the sun goes down in LA's summer, that hot pavement is going to stay hot for longer.
Yeah.
And so we do that. We take pictures of that difference with Diviner.
Wonderful. That sounds like really cool stuff, and thank you for bringing up the LA heat. It is at the forefront of my mind right now. I want to know, how do we translate this science into a booth for EYU? Because I'm sure we're not showing them all of what's going on.
That's a great question. Yeah. So we have, I think, one of my favorite booths. I have to give credit, the people with the projector map and the sandbox. That's one of my favorites, but I love a sandbox.
We record this podcast in the room with the sandbox, and it is mentioned probably every other episode.
It's so cool.
Because my guests are just staring at it.
I'm thinking about it because I just love that one. But we have a really cool exhibit where we have a thermal camera. And thermal cameras can be anything from just a little infrared sensor to tell you, how warm is your forehead in your thermometer, right? Or it can be a camera. You might think about like night vision, you maybe have seen like predator vision in film, and
ghost hunting and
exactly
stuff. Or on Big Brother when they turn the lights off and they can still watch everybody talk.
So that is a different, that's also infrared.
Oh my gosh, you know about this.
Yes. Well, there is near infrared, which is your TV remote works in near infrared. And so when you actually press a button on a TV remote, it actually sends out a flash of light. Those are infrared flashlights.
This is how they talk to each other.
This is how infrared sensors talk to each other. Any infrared, any TV remote or anything like that is actually flashing in the infrared when you push buttons. You just can't see it.
I thought it was magic.
But if you actually use those cameras that they use in ghost hunting and TV and all that, you can actually see, like, it'll flash.
Is it like a laser or more like a flashlight?
It's a flashlight, which is funny because it means the sensor is just looking to see if it's bright.
Yeah.
But there are infrared lasers, but that's not what we do. We use thermal infrared. I think it's called FLIR, or FLIR is like the brand name, but it's a little bit longer wavelength, so a little bit farther into the infrared. And that's where you start to see temperatures, or rather you can start to make comparisons of, something that is 98 degrees Fahrenheit is going to show up differently than something that's 70 degrees Fahrenheit, or maybe 32 degrees Fahrenheit. So what we do is we have different things at our booth. Hot things and cold things. My favorite is the bucket of ice.
Oh.
So if you come by the EYU booth for Diviner, we always try to bring out a big bucket of ice, and then you can pick up a piece of ice. First, we'll let you see yourself in infrared, and you'll look very different. You'll see your face will be hot, your hands will be hot, your jacket or your shirt, your clothes will be a little cooler, because they're sort of keeping the air, the warm temperature in. That's why we wear
insulated.
These things. Exactly. But the fun thing is that people will see themselves and then they'll pick up the ice.
Yeah.
And when you pick up the ice, suddenly your hands go dark. They go cold. And you can see, you can draw on yourself.
Yeah.
And you can see where the ice was because it'll leave a trail of cold.
Oh.
And you'll feel it on your skin, but you'll also see it with the infrared. And I just think that's really, really cool.
That is really cool. I have a question for you.
Sure.
What if you had a really strong fever and you walked in front of your TV?
If you had a really... Oh, you're thinking about...
Would it accidentally turn on?
So, no. And the reason is those remotes work for, I think it's like signals. You know, you can think of like Morse code, right?
Yeah,
There's going to be a specific series of flashes or whatnot. But that's a great question. We can actually see TVs in the infrared.
Oh, okay.
And so if you point it at like a computer or a monitor, you'll see like the hot parts of your screen. You'll see like where the light is being projected into like the flat screen TV. You can see where those elements are because they'll be hotter. It's really fun to look around, just to look around like any room with a thermal infrared camera. Very interesting.
So my physics teacher once brought one into one of my classes. This is Professor Tom Murphy at UC San Diego, and we were in this class called Thinking Like a Physicist, where we just like did random stuff every day.
Sure.
He brought an infrared camera in, and he's like, for privacy reasons, I won't point it at anybody's chair, because you can tell when somebody has recently passed gas.
Amazing. Yes, absolutely.
But they are just so entertaining. I love the cold nose and everything. And what I really like about your booth is that you guys took the science that you're doing on the moon and you brought it to the people instead of just saying, like, here are the pictures we took of the moon.
Exactly.
You said this is the technology and you give it to the kids.
And we love giving out pictures as well. We've got a lot of great maps and like pictures that we've taken from the Lunar Reconnaissance Orbiter, not by Diviner, but by, you know, optical cameras. And you can see things like the Apollo landing sites, and you can see their little footprints that the astronauts left 50 some odd years ago. You can still see them out on the ground, you know, what crater they thought was interesting, because they'll walk back and forth to it a bunch. It's really cool.
That is cool. So you believe the moon landing was real?
I should hope that everyone believes the moon landing is real. We can see it. We can take pictures of it.
So somebody who doesn't quite believe in the moon landing should also visit your booth so they can see the pictures.
Yes, yes. We also have some very interesting conversations at our booth. Many people who have questions about the moon landing will stop by, and the same thing I'll say is that, look, there are a lot of people who would have loved to prove us wrong, and they said, wow, congrats, you landed on the moon.
I'm giving you flack for this because as an alien scientist, my life is filled with very random questions and very random people.
Of course.
But like I mentioned earlier, you have actually been with Diviner longer than I have been with EYU, which means you experienced Zoom EYU. What was that like? Yes.
So we had a very excellent and influential and a clear-eyed leader in our department by the name of Tyler Powell.
Okay.
Was the leader of our student organization and contributed a lot to EYU. And he encouraged me to join the team. I was very new. I had only been, at UCLA for about a year. And he said, yeah, come on, we're going to do Zoom EYU. And so we recorded a few demos. We recorded the ice demo. We baked a sheet of sand, or we baked a tray of sand.
Tasty.
And then, right. And then, but we put some rocks in it. And so you could see then when you let it out to cool, you could see the temperature of the sand changing at a different rate than the temperature of the rocks. And
it's a really good analog to the moon thing.
Exactly. And so we actually took the opportunity to do some things that were a little different than our usual booth, just because it was it was a different time. It was a different format, but we got some good questions, and we'd show the demos, and then we just talk about it and hear people's questions. Like, we love questions. I'm sure you know this, but I just want to say, everyone loves questions.
That's normally the next question is like, what are some things that stood out to you that kids say when they go to your booth?
Oh man. So I gotta admit, the best questions that I get are from the high schoolers.
Nice.
And that is because the high schoolers, I think that infrared light and these sort of different wavelengths, it really helps if you've been through like even just your middle school physics class.
Sure, yeah. You've already seen the electromagnetic spectrum.
Exactly. Once you've seen the electromagnetic spectrum, we can really have a conversation about it.
Yeah.
And I'm happy to, there's such a process of discovery at all ages with infrared light and with seeing things in a different way. But I love the questions that I get from high schoolers. And the high schoolers will ask questions, about like, okay, well, can we see this or can we see that? Or like, what does it mean if it's hotter or colder? Or, would we be able to see people on the ground? And then you can talk about things like resolution and sort of the quality of a spacecraft. And I think that there's a lot of stories to be told about exploration there, that like when you can get into sort of the tougher stuff.
Yeah.
However, I also have to admit, I think we get a lot of good questions from high schoolers because anyone younger than high school is so captured by the infrared camera and being able to see themselves on screen that they're just having such a good time, like, taking off their hat and putting their hat back on and drawing with ice, you know, like smearing their cold hands on their friends' faces. Like, the amount of, like, jumping around, we have a very kinetic booth. We have a very...
That's funny.
Active booth.
Because there's no assigned movement.
There's no assigned movement, but boy, do people love to jump around and wave and see themselves on infrared. And I'm no exception. I love it too. You know, I set up the booth and then I play around with it for 15 minutes before anyone else shows up.
And this is why our booth leaders and volunteers must show up an hour prior to the event actually starting. You need to pick up your materials and set up and be fully ready and prepared. Somebody has to test the camera.
Somebody has to test the camera, and somebody has to go get the cables if the cables are missing.
Yes. We have cable drama every year. But anyway, it's so hard to mention Zoom EYU without another shout out to one of our favorite people of all time, DJ Rockstar Abijah Simon, for carrying EYU through the COVID years on 2 different software platforms and bringing us back in person in 2022.
Yeah, I have to admit, I was really impressed. I mean, I had done some undergrad, like, science outreach when I was at UT Austin, but it is just really, really something else.
Well, thank you for your service and your continued service. Is there anything else about Exploring Your Universe that you'd like to talk about before we switch gears?
I just hope that everyone shows up, because it is a great time. You know, it really is. I'm just, you know what, I will say, actually, my favorite interactions are not just with the kids, but also with the parents. Yeah. Seeing that there's just no limit to the age that people engage. And we have some really great conversations about, like, the Legos that we sit out, you know, or the, you know, just the pictures that I just love it. I love every bit.
Exploring Your Universe is truly for all ages. November 2nd, 12 to 5. We're going to switch gears here. How did you become DJ Solar Max? At some point you were DJ Solar Min. Sounds like there was some Texas in between. Where are you from?
So I am originally from Richmond, Virginia. Cool. And I went to school in Austin at the University of Texas, where I studied physics, astronomy, and science policy.
Wow. Were you a double major?
I was a triple major.
What?
Yeah. I'll give my favorite fun fact about that, and that is that if you get 3 diplomas, the proper plural of diploma is diplomata.
What?
Isn't that fun?
That is fun.
At least that's what I looked up when I, looked it up when I was when I graduated, and I was like, what do I call these pieces of paper?
And you're wearing like 10 different sashes.
Yeah, exactly.
My diplomata.
Exactly. But, so I studied physics, astronomy, and science policy. I always sort of wanted to be a science communicator somewhere in the gap, or on the bridge between science and the public. Yeah. And so I met, like many of us, have always wanted to work at NASA. Sure. And so I actually, while I was an undergrad, I had the opportunity to take an internship at NASA headquarters doing congressional affairs.
This is embarrassing, but where is NASA headquarters?
That's a great question. NASA headquarters is in Washington, D.C.
Oh, really?
Yes.
They're that federal?
Well, it's the National Aeronautics and Space Administration, so, it's a good place to put the headquarters. Now, admittedly, the headquarters is not the biggest center. In fact, I suspect it might be the smallest, or if not, one of them. I think there's...
Ames?
There's Ames and sort of JPL in California. There's obviously Houston is the Johnson Space Center. Kennedy Space Center is where we do our launches. Yeah. There's the Michoud Assembly Facility and Stennis Space Center down in the Gulf Coast, along with Huntsville, Alabama's Marshall Space Flight Center. There's Glenn up in Ohio. So it's all over. And I know that it's all over.
Because you've been to all these places?
No, I haven't been to all these places, but I my job actually in 2015 as an intern was to help Congress people understand that, like, NASA is not just in Florida. NASA is not just in Houston. The classic line of Houston, we have a problem. That's where that's where NASA's human people.
I didn't know that's what it meant. That's so funny.
Yeah, so they're literally talking to NASA Houston.
Okay.
But, NASA sources their parts, there's aerospace grade screws from a little shop in Wyoming. Yeah. And they do that to make sure that the entire nation contributes to
Yeah.
the space program. So I loved that internship. It left an impression on me, and that's why I wanted to do this space policy.
Mm-hmm. Oh, so you had this internship before college, or
Well, it was during college.
Okay, so you picked up a third major.
Yes.
You're crazy for that.
And it was just excellent, and I really loved it. And so I went back to NASA actually after I graduated for 3 years, mostly at headquarters, though mostly back at headquarters, where I was working on Mars human exploration, and actually the Mars Reconnaissance team.
You love that word, reconnaissance.
Yeah, we're back to reconnaissance, and I really loved. I mean, that was a very fun time in my life. You know, being like early 20s in DC, I was living with a couple friends, and it was just flawless.
Yeah.
But I knew sort of that when you spend time in DC, or rather, when you spend time in NASA, there's a lot of smart people around there. And I thought, wow, I should really go back to school. I should really try and get some research experience, you know? And so I spent some time at NASA Goddard, which is in Maryland, and I was doing astronomical research, or rather, I was using a radio telescope in the Atacama Desert down in Chile.
We know this, ALMA.
Yeah, I was using ALMA to look at Mars. So it was my Mars reconnaissance at headquarters, went to Mars observations at NASA Goddard. And actually, when I was looking to go to grad school, I applied to a bunch of different places, and I was having a conversation with Professor Page at a conference, and I was telling him about my work. And I love Professor Dave Page. He is great. He is
He's in a rock band?
He is one of a kind. He is in a rock band. He's done a lot. He's been very influential in a lot of different ways. You know, I was sitting there talking with him, and I swear his eyes were glazing over. He was not cluing in. You know, he just wasn't. He was a big conference, you know, and I was just some guy who was telling him about my research. And then I said, you know, oh yeah, with ALMA we can do atmospheric spectroscopy.
I didn't know that.
Yeah, so ALMA has the reason to do it is because ALMA has better spectrographic resolution than any spacecraft you can send. You can, you know, we're orders of magnitude better at seeing spectral lines than you would be even with a spacecraft that's right over the planet. Okay. The downside is, of course, resolution, right? Yeah. Or rather, spatial resolution, right? If your spacecraft is in orbit looking straight down, you know that the signal you're getting is from straight down. If you're taking a picture from Earth, you're really trying to pull a lot of information out of that one little dot.
Yeah, we call our one little dot the star, the planet, the star system.
Exactly.
Yeah, I'm a radio astronomer.
Oh, I did not know that.
Yeah, I do radio SETI, so I use the Green Bank telescope, but I
did see your sticker on your laptop. That is excellent.
I did make it to the top of the Green Bank telescope.
Wow, that's crazy.
There's no air up there. But anyway, there is supposed to be air up there. This is a weird fun fact about me. Everybody else is like, the air up here is so fresh, and I was like, I literally can't breathe. I'm really allergic to pollen, and whatever was pollinating in the trees right at the height of the telescope just took me out.
So I actually grew up going skiing at the mountain that is like 3 miles from Green Bank.
Sure, yeah.
Snowshoe, West Virginia.
You can see it from,
You definitely can. And so I know that there is at least some air up there, and it's quite nice. I'm sorry it afflicted you. You should try going in the winter.
I might consider that. Well, it sounds like Dave Page recruited you from a conference?
Yes. So that was the takeaway from that story.
Crazy.
Yeah, is certainly, it's really just, I mean, my journey was one of touching a lot of different things and seeing what stuck. Yeah. And in part, just making sure that you make human connections with people. Yeah. Some human connections don't work out, but at least then, if it doesn't work out, you'll talk to the professor and they'll say, look, the hiring committee said no. and you get something a little more personal than just a letter in the mail.
Yeah.
Yeah.
I need a soundbite of you saying some human connections don't work out and like push this button every time somebody's like dating someone who's not right for them.
Some human connections just don't work out. Yeah.
But sounds like this one did.
It did. And I am ever thankful for it because it is great to be at UCLA.
But you mentioned you're very interested in science communication. Our previous guest, DJ Sarah Michelle Geller, aka Ben Paul, is actually our first professional science communicator we've had on the show. So you should definitely check that episode out when it comes out. But anyway, you have like a lot of science communication experience. What are some of like your highlights and favorites?
I've done 2 with when I was an undergrad studying astronomy and physics. I was a little more of an astronomer. Now I'm a little bit more of a planetary scientist. So I'm more focused on Mars. Before, I was very into the James Webb Space Telescope. And I still love the James Webb Space Telescope.
First, could you tell our audience the difference between an astronomer and a planetary scientist?
Sure. Planetary scientists, astronomers take more beautiful pictures, but planetary scientists take pictures that you can understand.
That's a good one. I like this one.
It is simply, when you're an astronomer, every picture is just little dots of light or clouds. Those are your 2 options.
Yes.
And then you compare those to the pictures that we see from planetary science, which is not the study of other stars and other star systems, but the study of the planets in our own solar system. We get these beautiful images from Pluto or from the surface of Titan, right? Like these things where they are real worlds. And, the Soviet space lander that landed on Venus and came down on this unbelievably unimaginable sort of intolerable world, hot and completely alien to life.
The top of the Green Bank telescope.
Yeah.
I'm kidding. It's so nice up there. It's just me.
Certainly not as hot or thick atmosphere as Venus, but there are rocks.
Yeah.
And there's like
it's tangible.
There's like valleys, and the picture has like terrain in it, and you can see it, and you can be like, oh, that's like a picture I would take with my phone.
Yeah.
But it's of another planet, and that was just crazy to me. So that's admittedly why I got pulled over into planetary science. But the outreach I did for James Webb, I got to do outreach at South by Southwest, which is a festival in Austin.
Yeah.
Usually thought of as a music festival, but they do like a game expo and a movie thing, and we were there for the interactive portion, which was like basically a bunch of weird tech entrepreneurs promising things about space and science. And this was back in 2013. And that was when I got pulled in to support the James Webb Space Telescope's booth. They just asked UT Astronomy, like, got any undergrads?
Yeah.
And so I went and I did that, and that was it was lovely. It was talking to thousands of people who were all interested, and I think that was my first real science communication. That was where I fell in love with it.
And at some point, you gave yourself the name DJ Solar Max.
Yes.
When did you do that, and how did you come up with Solar Max?
So the short answer is I participated in Astronomy on Tap. UT Austin has a great astronomy outreach game. They're doing well there. But they participated in Astronomy on Tap, which is basically they send astronomers to local bars to do talks.
Yeah.
And they're pretty fun.
They're fun.
And I gave mine actually I gave my talk on how Congress and NASA's legislative branch interfaces with, like how it enables science. Because a lot of people love science, but they don't know how we actually do it. How did the bills get paid? And so I actually went and I gave my talk on that. And it was a good time. And I was told I needed a name. So Solar Max.
Yeah.
Do you know what Solar Max is?
This is when the sun is at its highest point?
So when the sun is at its most active.
Oh, okay.
So when we think about like aurora,
yeah,
they happen when the sun is very turbulent and throwing off a lot of plasma.
Yeah.
And so solar max is when it's at its fullest or at its peak, and solar min is when it is least active. But when you've got a name like Max, you look around and you see what fits.
That is very lucky.
I'll tell you one more thing about Max and Min.
Yeah, go ahead.
And that is that as a freshman undergrad, my dorm mate that I was randomly assigned was a guy named Min.
That's crazy.
It is true story.
You guys should have been a sitcom.
We were both very alike and also very different.
Okay.
I think. But he was an extremely nice guy. I recognize I was the bad roommate. Like I was the loud one. I was like up late playing video games, and he was like studying hard and going to bed on time.
I feel like we were all the bad roommate at some time in our lives.
I'd like to believe that. It's not every day that you know it, though.
So federal funding is what funds science, and it has funded some of our greatest discoveries. There
Sure.
are unfortunately some current events right now of us not getting federal funding. What are your thoughts on this, and what should the public know about what's happening at UCLA in particular?
Okay. That's a big question.
It sounds like you're an expert on some of this stuff. That's why I'm asking you.
I try to be informed, but I will say the number one thing. I'm gonna give the hopeful note out
Yes,
up top.
yes.
The number one thing is that when I was an intern and going to the halls of Congress, we would visit and we'd hand off. We'd basically do outreach, but to Congress, and so
Yeah.
we would go visit these congressional offices, and everyone thinks that Congress is like, all they do is take money from big oil and whatever, right? And like that's the only thing that matters. But
That is what I often hear.
the truth is, and I've seen this firsthand, and there is data from lobbyists and congressional staffers. Your congressperson is one person. They have a team of like 10 to 20 people
Okay.
that is their staff. And their staff will be assigned to hear issues, just learn about issues.
Like they pick up the phone, they read the emails?
They pick up the phone, they read the emails, they'll take meetings.
Okay.
And so they hire all these people. It's like more than a dozen people
Okay.
just to listen to you.
Yeah.
The whole point is to listen to you.
Yeah.
And I've seen congressmen do stupid things because their constituents asked them to.
Okay.
Okay? Like, just make fools of themselves.
Yeah.
Because the only thing that matters to them is that their constituents vote for them again.
Sure.
And so, if you call your congressperson, they will answer. Not that person in particular,
Yeah.
but their staffer will answer.
Okay.
And their staffers, and this is the thing that blew me away. I'm going to paint this picture visually. The staffer, when you enter the office, there are like 4 desks, and each desk has a giant sheet of paper. And on that sheet of paper, the staffers are writing down everything they hear. Okay?
Wow.
They just, whatever it is, they write it down. They
Okay.
don't say, oh, this isn't relevant. They just write it down.
Sure.
And then they bundle it up and they send these notes to your representative.
Yeah.
And your representative will look at these notes and say, wow, if 100 people came into their office and said, ban cats, we're
Yeah.
dogs only from here on out.
Yeah.
Cats are for losers.
Yeah.
Your congressperson would go on the news and say that. Because
Okay.
they care. They really do.
Okay.
And so if it's not a thing that, there's some things that are politically you can't touch.
Sure.
Like politically, you say you're a Democrat or you say you're a Republican, so you have to say a
Yeah.
certain thing. But space is never one of those.
Yeah.
Everyone likes space.
That's
It's
true.
just a question of how much do you remind your congressperson that space or science exploration is a priority for you. This is a long-winded way of saying there is hope because your representatives do care about what you have to say. And so if you say, we care about space science, we care about space science funding, this is meaningful to our communities for these reasons, they will listen. I swear to you, I've seen it with my own eyes. It's
I
not
trust
some
you.
grand conspiracy.
No, I mean, this is great.
I will say I don't want to. The problem is that there is a political football being thrown around right now.
Yeah.
And like, we are in, to use a tired term, we are in unprecedented times.
Sure.
Politics is rancorous. Rather, politics became quite rancorous in the 21st century. And it has made it very difficult for people to reach across the aisle. And, to get the Republican senators of the Gulf Coast to work with the Democrat senators from California and New York,
Yeah.
who all have NASA centers in their districts. Used to be they'd all get along.
Yeah.
But now, because of TV and sound bites and social media and everyone, like the thing that they can show their constituents now is how much of a jerk they're being to the other side.
Sure.
And that makes it very difficult to work for or work towards things that should be bipartisan should get bipartisan support, like exploring our cosmos, you know, humans on Mars and robots on Jupiter, you know, like these are things that we want.
Yeah.
And, you know, that should be an easy dunk, but, you know, here at UCLA, we are sort of caught up in a much bigger political picture that goes beyond space science. It honestly goes beyond science.
100%.
And it's just tough.
Well, thank you so much for sharing that with us. That was a really great framing of everything, and I love how everything you said can really be applied to, like, any time. People can call their Congress people at any time.
Oh, yeah.
And I didn't know that Congress people actually, like, listen when you call them, so...
They do.
That's really great to know.
Yeah.
Anyway,
sure.
So at some point, you were DJ Solarman. You were a small...
DJ Solar Max. Oh, I see.
Like when
I
you
see.
were
It's
a baby.
a pun. Yes.
Yeah. I'm talking about children. EYU is about children.
I understand.
Yeah. At some point, you were some child wandering the earth.
Yes.
Let's say you were a child wandering into EYU. What would you have wanted a volunteer to have said to DJ Solarman?
That's an easy question for me, actually.
Really?
It is a super easy question. I want them to tell me the coolest things they know.
Oh.
It's simply a fact that I loved learning about stuff. I checked out every book on sharks and volcanoes and asteroids and all that. Every book I could from my school library. I just wanted to know all the things. And EYU is a great place to know all the things.
It is.
And there's a lot of smart people. And I think they have a lot of fun stories to tell and a lot of interesting factoids and tidbits. And if you're a kid who loves factoids and tidbits and going home to Thanksgiving or, you know, telling your grandparents, like, I learned these things today. That was me 100%. And I loved it.
That was me too. Thank you so much for joining us today.
Thank you for having me.
Where can people keep up with you, your science communication?
It has been a long time since I have engaged on social media as a contributor, but I actually do still have the Instagram handle at today's Space Max. Not sure exactly how to spell that. I haven't done it in some time, but at today's Space Max, I'm sure you can find it. My entire social media, I turned my personal Instagram into a science communication Instagram because I just posted space facts every day for a year.
Full commitment. I love that.
Just, you know, yeah, because why not? And that was a lot of fun. So you can find me at today's Space Max, and I'm happy to answer questions about politics or science.
I think we should all DM today's Space Max and ask him what the coolest thing he knows is.
All right. I'm for it. Or come see me at EYU.
Absolutely. November 2nd from 12 to 5 on the Court of Sciences.
Perfect.
Is there anything else you want to say to our listeners before we sign off?
You know, I'll see y'all there. That's
Yes.
what I'll say.
See everyone there. This has been DJ Stellar Cloud and
DJ Solar Max.
Never Stop Exploring.